Okay, lesson 31, the unit circle. So, looking at the unit circle here, this is going to be something like pretty brand new to you guys. You're going to be getting tired of this unit circle probably by the end of it, but it's pretty key part to this whole unit. Actually, like the next 3 chapters are all trigonometry, and this is kind of at the center of it. So, here's the idea on the unit circle. We are going to define. We're going to say the center of our circle is at the point 0, 0. Okay. And then we are always going to have the arm length of 1, right? So like the radius is 1, whatever you want to think of there. Okay. So that's going to be 1. And then along the way here, we've got some points, right? So these are actually going to be like probably the simplest points that we have. This would be the point 1, 0, right? Which just really means that you have an X value of 1 and a Y value of 0, which would make sense there, right? This is just a Cartesian plane like we've been using. Okay, if I go straight up, then you've got, well, an X value is 0, a Y value of 1, right? Because the radius is 1, right? So that's the length of 1 at that point. And then similar here, right? -1, 0, and then 0, -1. And these things are happening at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay, now we've been thrown into the mix radians, right? So we're going to be talking about those along the way. But then as well, just to kind of get our bearing on some generally what some angles are, there's some other special ones. So this was obviously a special point on the unit circle because it's, you know, easy and it's straight there. But there's actually going to be 3 more in here that are also special angles that we're going to be using a lot. So I'll show you how to find those special angles on a unit circle down below here. Okay. And it'll make a bit more sense, I think, as we go. So in order to get these special angles I'm talking about, we're going to go over special triangles. Okay, so we can just find there's certain triangles that just have these properties. So we're going to be able to use that in our unit circle. So if we make a right angle triangle, right? So like one of the angles is 90. Oh, that was a terrible 90 degree. So 90 and 45 and 45. Okay. Well, if I look at that, well, we can say, okay, I know that on my unit circle, I'm going to make the radius in that case is going to be 1. But what I'm doing here, I think maybe it'll help, is I'm actually trying to figure out at this point right here, when we have 45 degrees, what will the angle be? Or I should say what will the 2 side lengths be, right? Like what will my points be there? I'll have like an X and a Y. And what will they be, right? This is what I'm after here. So if I have like a radius of 1 from there to there, then if I just call this X for a second and this Y, right, then I can set this up with a little Pythagorean theorem. I can say, well, I know this part of it, that X squared plus Y squared is equal to 1 squared, which is just 1, right? But if I go by the fact in a special 45, 45, 90 triangle, the length of X has to be the same as the length of, the length of Y has to be the same as the length of X there, right? Because it's 45-degree angle. They would be the same at that point. So in that case, what I can do is say, well, I'll call this X squared plus, and then Y is the same as X. So I'm just going to call that another X squared is equal to, I'm just going to call that 1 now, because 1 squared is 1. Do a little bit of algebra here. I could say X squared plus X squared. That's 2X squared is equal to 1. I'll divide by 2, divide by 2. Okay. And then, so what we have left here is I'm going to go X squared is equal to a half. And then I'm going to square root. So square root, square root. And if we do that, we end up getting X is equal to 1 over root 2. Now that's true, that is right, but we don't really like having those square roots in the denominator, right? So if I'm going to actually start using this as a point, I'm going to need to rationalize the denominator. Okay, so rationalize, remember, just means I'm getting rid of that square root in the bottom. And this is how I do it, right? I multiply the top and the bottom by square root of 2. So root 2 times root 2 on the bottom would cancel those. So in the end here, this would be the same thing as saying root 2 over 2. Okay, so what did that just do for us, right? What that was, right? I said X is that value, right? So that was X. That's this value here we said is equal to root 2 over 2 if the hypotenuse is 1. Okay? So back to our unit circle here, what I just found there, if I turn this into a little triangle from like there and there, well, this was root 2 over 2, right? The length of x there was root 2 over 2. So that would be my x value at that point. That'd be root 2 over 2, right? That'd be that point for my x. And then remember, for a 45-degree angle, they're the same, right? So your x, like this length for your x is the same as the length for your y. So that would also be root 2 over 2. So at 45 degrees, those are my 2 points. Those are my x and my y values for that point, okay? You guys won't need to memorize how to do this every time, by the way. I'm just kind of showing you how we arrive at that, right? So that's not going to be a huge component. You don't have to do that every time you do a trig question. But here, now the next one, if we take advantage of the 30, 60, 90, well, here, first off, let's take a triangle that is 60, 60, and 60. Right, so like an equilateral triangle, all the angles the same. And then if I cut this thing in half, I'm going to cut this thing in half like this, right? Well, what I end up with is a 30, 60, 90 triangle, right? Because this side would be 60 degrees. If I cut this in half, this would now be 30 degrees up top. And then I just made a right angle triangle, so that's 90 degrees there, right? And if I use that triangle now, so if I use that part of it, I'll redraw this to kind of clean it up. And then, so this was 60, and this is 30, and that's 90. Okay. And again, my length of this triangle, because on a unit circle, we said the length will always be 1. I'm going to put a 1 there. And then we're after what is the x and what is the y. But in this case, we get a little hand here. This originally was a equilateral triangle, right? So before I cut this triangle in half, if this was 1, this was also 1, right? Both those side lengths were 1. And I cut it in half. So then that would make this a half, right? That would make that 1/2 long. And now I have 2 sides of my triangle. So if that's a half, then I can look for y. So we can do a little Pythagorean theorem again. So this time I'm going to say, I'll call that b squared is equal to c squared minus a squared. Just Pythagorean theorem rearranged a little different, right? Okay, so I'll call that, we'll change that to a y, right? Because I'm looking for y squared. So y squared is going to be equal to, and then 1, right? That's my hypotenuse. So like 1 squared minus 1/2 squared. So then y squared is equal to 1 squared is just 1. And then a half squared is equal to a quarter. Okay, and then 1 minus a quarter, so y squared is going to be equal to 3 over 4. Okay, and then I'm almost done. I'm going to take the square root of both sides. So square root. So we get y is equal to, and that would just turn into root 3 over, and then square root of 4 is 2. So there, we found all of our pieces, right? So it's root 3 over 2. That's what this is, root 3 over 2. So now that's actually all we're really going to need to do, because we're going to find these triangles in other places. Here, I think I have it below. No, I don't. Sorry for the scrolling here. Let's draw it on here too. So what we just found here was this angle, right? So let's say if this was 30 degrees. No, sorry. Let's say if this was, we'll do this one up here because it's more similar to what we just did. So let's say this is 60 degrees, right? That's what we just had there. And we drew that same triangle in there. So that's 60, that's 30, right? And that's 90 degrees. So we just found that, well, this one was a half, right? Our x was a half. And then this length here, that was root 3 over 2. So that point right here, right? That point on the unit circle would be 1/2, comma, root 3 over 2, right? So now we found that. And that's actually all we need, because now if you think about it here, if I drew, let's say, a 30-degree angle from like there to there, and this is getting messy, sorry. Well, this is the same triangle. It's just we're looking at it a different way. Now, this would be 30 degrees and this would be 60 degrees, which would make this a half, right? Up and down, and then make the bottom √3/2. So that point there would just be the opposite. It would end up being √3/2, comma, a half. All right, so that's all we need, because now that we have those points, we're going to be using those everywhere. I'm going to draw them on this side, right? Like that one, and that one, like on all the sides there. I'm going to do it down here and everywhere else, right? So this is where I want to bring you to a little Gizmo thing. You can see that trick if you do your QR code, you can go to it from there too. But here's, yeah, so if I bring you to my Gizmo, we get this, right? Now, this is really just going over the same thing. So you can see over here, if you can see where my pen's pointing at here. Well, the angle is 45 degrees. That's what I'm on right now. I'm on 45, I'm on 30, I'm on 60, right? And all the way around like that. Okay. Now, if we change these angles, right? So like our 30 degrees, maybe we'll just do like 1 here. So let's actually do the first one. So it tells me that at 30 degrees, it's actually the same as pi/6 radians. So we're gonna have to, I'll show you how you would find that, right? We've actually done that already. So if we were gonna do that one, we'd say 30 degrees. So 30 degrees over, oh, sorry, actually we'll do it this way, my bad. We'll get our ratio, right? Pi is the same as 180. So I'm going to set it up as my ratio. Pi/180 is the same ratio as x over 30 degrees. And I'm looking for x, right? Because I want to turn this into radians. Okay, so I'm going to multiply both sides by 30 degrees. So they cancel. 30 degrees. And then just simplifying that, we end up getting, well, that just becomes 6 on the bottom. So that'd be the same thing as pi/6. All right, so that's where we got that from, right? And you could do the same thing with all of the angles all the way along, right? So this was 30 degrees. That would make this 45 and this 60, right? And then this would be 90. And then you can just keep on going with this pattern, right? So here, let's look at our Gizmo again here now. So knowing that, we can see that it actually tells us in the question here, right? That our x value up here, right? √3/2 and then a half. So that's the x value, that blue arrow right there, right? It's saying that that's equal to √3/2. And then here it's going to be √2/2, √2/2. Those are our x and our y points, right? And yeah, so, and then the other one we can do here on this little Gizmo, you can change it up. So right now I'm looking at degrees, right? Saying this angle is 45 degrees. If I change that to radians, it'll say that's the same thing as pi/4. And then you've got pi/3, right? And again, just notice these numbers, right? So our x and our y value, that's a half, and that's √3/2. They're always going to be those numbers because they just come from those special triangles, right? This one makes sense too, right? So if we've got right up and down at 90 degrees, we've got the point 0, right? Because the x value is 0, and the y value is the full length of the arm, so that's going to be 1. You keep coming around, we end up with now, well, and this makes sense now too, right? Our x value is same thing, but now it's -1/2, right? Because the x value is going to the left, but our y value is positive. It's going up and down. And then carrying on, -√2/2. So our y and our x are the same magnitude, right? They're the same number there, but the x is negative and the y is positive. Okay? And then so on, right? So you can go all the way. It's called trig tour because you can just keep on going around and around. Okay? Don't worry too much about this cos theta, x/1 and all that kind of stuff yet. That's actually the next lesson. I'm going to explain more what's going on there. But if you want to, just to see where we're going, if you hit this one, you can actually see where we're going to go with this, that we're going to start turning this into a graph, into a sine graph or a cosine graph or a tan graph, right? You can change it up. Okay, so that's on the horizon. That's where we're heading next. So really, I'm going to do one question here, but what I want you guys to do for your homework when we get going. No, I shouldn't have erased that. Here, put that back. Yeah. When we get going here, I'm going to get you guys to fill this in. So you can use your trig tour if you want to go around. It'd be great though if you did at least a few where you change the angles into radians, so you know how to do that, because you will be responsible for doing that, right? And then, yeah, for this course, you guys are supposed to memorize this. I know that's kind of a drag, but Yeah, you do have to start to figure out the patterns that are happening there. And then probably what I would do is if you're in an exam or anything else, you could sketch out 1/4 of this thing, and then you can kind of figure out what the rest would be from that quarter of it. Or do the whole thing, maybe right before you get going, just get it all down on the page, and then you got it for the test, right? But other than that, yeah, you guys are really going to want to take advantage of this unit circle. Okay, so yeah, you guys will fill that in after. So I'm just going to do one more question here, just to kind of give you an idea of the style of questions that you're going to get. So let's just do this one. So this might or might not be in your notes, but if not, just kind of follow along. Okay, so the question says points A, and it gives you 2 points here, right? Points A and B, right, are 2 points on the unit circle. It says if point 0, or point O, I should say, is 0, 0, so the origin, it's the center of the circle, and it says then the measure of the smallest angle, AOB, in degrees is. All right, so what is that even talking about? So they're saying that we have a unit circle. Okay, so we have a unit circle. And they told us that we have the point 0, 0 as the center. And then we've got point A and point B. So let's actually just roughly put those where they belong. Maybe let's make our axes here too so we can get our bearings. Okay, now point A, √3/2, right? So √3/2. So where is that going to be? Sorry, one sec, guys. Okay, so yeah, √3/2 for your x value, right? So that one is going to be at, well, √3/2. That would be this point, right? So you've got √3/2 over 2, sorry, √3/2, comma, and then a half. And just remember where that came from, right? That was still just that 30-60 triangle, right? And those are just the side lengths of those triangle that we had. So that's our first point. That's where we're at. And then, we'll call that A. And then our second angle, or our second point, I should say, was at negative √2. So negative √2/2, and then √2/2. So that point, so it's negative, right? I have a negative x value. So that means I got to be over here somewhere, right? It could be over there on the top or on the bottom, right? But my x values are negative. But then I have a positive y value, so I know I'm up here, right? And this √2/, I know what that is. That's when it's 45 degrees, right? So that'd be right there. So from there to there. So this point, so point B, is going to be negative √2/2, and then comma √2/2. Okay, so now in this question, we're just kind of required to understand what those would have to be, what the degrees would be, because what the question's asking is, it says, what is the, what does it say? What's the smallest angle between, and it says AOB. So that's between A, O, and B. And it says the smallest angle because it could be saying this angle, or it could be saying like wrapped around the backside. But it doesn't want the backside. It wants the top one. That's the smallest of the two angles. Okay. So all we really have to do here then, if you think about it, let's figure out what the angle is from there to there. Then figure out what the angle is from here to here, and then just subtract them, right? That would give us the difference between them. That would give us the inside there. So let's do this one over here, right? Actually, let's do this A first. A is pretty straightforward, right? Your angle A there. So angle A, I'll do it like this. Angle A is equal to 30 degrees. We talked about that above, right? That would be your 30-degree angle. Okay, the first one. Angle B there is going to be, well, if you think about it like where this happens, that's when this is 45 degrees, right? So if I was making my triangle out of that thing again. Well, if that's 45 degrees, then what I can do is I can say, well, if I want to know what it is from like here to here, then that would be 180. That would be your angle B is going to be this equal to 180 degrees minus that 45 degrees, right? That will give us from there to there. So that's going to be your 135. And tell you the truth, I did this, but you guys will probably start to memorize where these are as you get doing questions too, right? So, but either way, that's 135. Okay, so then just in the end here, the difference between them has to be our answer, right? So then the angle between them, so maybe call that angle C, is just going to be 135 minus 30. So your answer here would be 105 degrees, right? That's what the angle between there and there would be. Okay, so that's the type of question that you guys are going to be getting. This is actually from an old diploma, that one there. So that's it. So make sure you guys do the questions and fill in your unit circle for next class.